All right, folks, next section. Find the currents across I1 and I2. I1 being this chunk right here, consisting of R2 and R3, and I2 being this chunk right here, R4, R5, and R6. I'm going to start with I1 because it's a little bit simpler. So I1 has got two components in series and a total voltage or total resistance of 17, which we calculated earlier. We know the voltage of this whole chunk right here because of our rules for voltages from page 285. Voltages in series share a voltage that adds to the total. So this chunk right here and this chunk right here have to add to 20. We know the voltage of this chunk because we calculated it a moment ago. So we just subtract that from 20 to give us the total voltage of this whole chunk right here, which ends up being almost 7. Okay, so if we know that the total voltage of this chunk right here is almost 7, we know that this path right here, I1, and this path right here, I2, both have that same voltage because voltages in parallel use identical voltages to other branches. So if there's almost 7 volts here, there's going to be almost 7 volts here as well. Okay, so once we know that, we go to V equals IR, our old friend. We know V, 6.9977, etc. For the reasons we just stated. We also know R. We calculated it before. It's R2 plus R3, 17 ohms. Plug that into our equation, which I've rearranged. I equals V over R, 6.9977, etc. over 17 equals 0.411630186. It's going to round to 0.4 amps. So this chunk right here we think is probably 0.4 amps. Okay, next section is the current across I2. So once again, we know the total voltage of that section is almost 7 for the same reason as the other one. We know Ohm's law, and we know the total resistance of that section because we calculated it way back at the beginning, 7.875. We just got to do the same thing again. Plug in our different numbers, and we get 0.888598497 amps. That rounds us to 0.9, and if we want to check our answers, a quick thing we can do is see whether I1 and I2 will add up to be the total current going across the whole circuit. Because the rule for currents in parallel is that each branch's current adds up to the total current entering the parallel block. Current entering the parallel block is 1.4, so we've got 0.9 here, we've got 0.4 there. Is that going to add up to 1.3? You bet your britches. Right there. Big old check mark.